Hello, thank you for watching this video. So in this video, we're doing question 2 of November 2019 question paper mathematics paper 1. And the topic is sequences, let me say, in series. Because I can see a quadratic sequence and the geometric series. So let's go. 2.1, which is what I've written there. They are saying you are given a quadratic sequence with numbers 321, 290, 261, and 234. So you're told that these 1, 2, 3, 4, these 4 terms, they form a quadratic sequence, right? No problem. So let's go to 2.1.1. They're saying write down the next 2 terms of the sequence. So they want you to find the next 2 terms of the sequence. How do you do that? Okay. First, you need to understand the sequence and see how it changes and yeah. So what we're going to do, we're going to find the difference between these 2, difference between the 2, difference between the 2. So let's get our calculator and say 290 minus 321. So this is equal to minus 31, right? Fine. Then 261, which is 261 minus 290. It's minus 29. 234 minus 261. It's minus 27, right? Fine. Then, if we want these, we need to continue, right? So that we can find the number that is sitting here and the number that is sitting over there. But in order to do that, you need to understand what this number is and what this number is. So to do that, let's find the second common difference of the quadratic sequence, because you know the quadratic sequence has a second common difference. So let's find it. So what is your minus 31, 29 minus, find the difference between the two, 29 minus negative 31. Negative 29 minus negative 31. It's 2. It's 2. It's 2. It's 2. Right? So, to move from here to here, go down, add 2, get here. You add 2, get there, add 2. So if you add 2, it will become minus 25. If you add 2, you become minus 23. That's where you are. So, it's going to be 31 plus 2, and then you get that. 29 plus 2, you get that. 29 plus 2, you get that. And 25 plus 2, get that. Same thing here happens as well. Say minus 31 plus this. Say 231 minus 31. 290 minus 29. 261 minus 27. 239 minus 25. Sorry, 234. 234 minus 25. You get 209, right? And then all your 209 minus 23, you'll get 186. So in your question, they are saying write down the next 2 terms. Therefore, next 2 terms are what? Are 209 and 186. Here they are. We're done here. So we move to 2.1.2. What are they saying in 2.1.2? They are saying determine the general term of the sequence in the form Tn is equal to an squared plus bn plus c. So they want you to find the nth term or general term for the quadratic sequence. So they want your Tn. And they're telling you that they want the Tn in the form an squared plus bn plus c. Right? No problem. First thing that you need to find is a. What is a? Is a. The double of a is equal to the common difference, right? So which means 2 times your a, which is the value here, is equal to your common difference, which is what? Which is 2. Divide by 2, divide by 2. You quickly get that your a is equal to 1. There it is. So we're going to take this one and substitute it back to our Tn. Which means our Tn like now looks something like Tn is equal to 1n squared plus bn plus c. We're done, found a. Now we need to find b and c. How do we do that? So you're going to use this Tn and find T1 with this Tn. So going to say, okay, T1 is equal to 1 into 1 squared, because you put 1 there and there if you want n, because you want your T1, right? Plus B times 1 plus C. So therefore, your T1, what is your T1? Your T1, you know it, is 321. Is equal to 1 plus B plus C. So let's transpose this to the other side. So you have 320 is equal to B plus C. So you get this equation here, which is incomplete. So what do? Go and find T2 or T3, whatever that you want. It can be even T6 if you want to all come out the same. So let's say now the T2 will be equal to what? Put the 2 there, 1 into 2 squared plus B into 2 plus C. So what is your T2? Your T2 is 290 is equal to 4 plus 2B plus C. So what is 290 minus 4? 290 minus 4 should be 286. So you have 286 is equal to 2B plus C. So here's the second equation. The only thing that you'll have to do now is to solve this equation simultaneously. Right? Fine. We're going to use elimination. You can use simultaneous if you want. Okay, so from here we're going to solve these two equations, this equation and this equation simultaneously. So we're going to say 286 is equal to 2B plus C. And the first equation is 320 is equal to what? Is equal to B plus C. Then you can use simultaneous or elimination. I'm going to eliminate. So I'm going to say 286 minus 320. 286 minus 320 is minus 34. It's equal to B. So here is it. So 34 minus 34 is equal to B. Then now to find C, one day substitute B there. So you say 320 is equal to your B, which is minus 34, plus C. Therefore, your C is equal to 320 plus 30, which is 354. Therefore, your nth term Tn is equal to n squared, right? Minus 34n plus 354. So here is your nth term, or your general term. We're done with it. So I think we can move to the next question. What are they saying on the next question? On the next question, which is 2.1.4, they're asking which term or terms of the sequence will have the value of 74. So they're asking at 2.1.3, which term or terms of the sequence will have value of what? Value of 74. They're asking which term of the sequence, or which term or terms of the sequence will be 74. So they want us to locate 74 on the sequence. Where is it sitting? Right? We're looking for its position. So on the nth term, what is its position? The position is n. We're looking for n. We know the term, which is Tnth term, is equal to 74. We know that 74 lie in the sequence, but we don't know the position of it. So we're looking for the position or positions for this, which is we're looking for n. So we're going to equate this nth term to 74, which is your n squared, as you can see here, minus 34n plus 354 is equal to 74. And then solve for n. So you have n squared minus 34n. What is 354? Minus 74. 354 minus 74 is 280. So it's going to be plus 280 is equal to 0. Then factorize this or put it on your quadratic equation. It's too big. I'm going to put it on the quadratic. N is equal to negative b plus or minus square root of what? B squared minus 4ac all over 2a. right? So let's substitute now. N is called negative b. What is your b? Minus 34 plus or minus 34 all squared minus 4a c, which is 280, all over what? All over 2 into 1. Therefore your n is equal to, or your n is equal to, so n is equal to negative minus 34 plus minus 34 all squared minus 4 into a c all over 2 into 1. Okay, that your n is 20, or your n is equal to what? It's called 14, right? Therefore, 74 is there. It's the what? The 20th and 14th term of the sequence. Done. We've located our 74. So we will find 74 at the 20th and 14th position of the sequence. We're done here. So we're going to move to 2.1.3 or 2.1.4. So and 2.2. So I'll clean the board and then we move to those positions, to those questions. Okay, so now we're doing 2.1.4, right? They're asking which term of the sequence will have the least value, right? So they want the position of the term that will have the lowest value, which means they want, if you're looking at this, it resembles your quadratic function, which is your parabola. You know, a parabola like this would have a shape like this, right? And surprise, surprise, even this Tn here will also resembles the same shape. So now, if this Tn have a similar shape to this, which is they want the position of that Tn over there, of that position, the position of the lowest value on this Tn over here. So let's go and find that position. So, your n of your turning points will be called negative b over 2a. Should equal to negative b. What is your b? It's minus 34 over 2 into 1. Right? No problem. What is minus 34? Oh, what is punch it in the calculator? This is going to be 34. Half of 34 should be 17. Right? So therefore, T17 will be the least term. Right? Or we can say 17th term will be the least term, will be the smallest. So the smallest term of the sequence is sitting at term number 17. And we're done with 2.1, right? Now we're going to move to 2.2. Okay, so now we're doing 2.2, as you can see here, right? 2.2 reads as follows. They're saying given the geometric series 5 over 8, 5 over 16, and 5 over 32 is equal to k. So you are given this geometric series. So when you sum the terms of this geometric series, your answer is k. So k is the sum of the numbers of this geometric series. No problem. So what are they saying at 2.2.1? At 2.2.1, they are saying determine the value of k if the series has 21 terms. So they want us to find the value of k if the series have 21 terms. Right? So which means the sum of 21 terms of this series is k. So we must go and find that is. Right? Fine. First, let's identify the series. Actually, we're told that it's geometric. So its a is equal to 5 over 8. And the r is equal to t2 over t1. Right? Which is equal to 5 over 16 divided by 5 over 8. Therefore, your r is equal to 1 over 2. Right? So we want the value of k, and we know k is equal to the sum of 21 terms of this geometric series. Right? And you know to find the sum of 21 or sum of terms of the geometric series is Sn is equal to a into 1 or r raised n minus 1 over r minus 1. This is the formula for finding the sum of a series or a sequence, but it's a series in this case. So, but we want the sum of 21 terms. So k is equal to the sum of 21 terms, which is a in the place of a, put a 5 over 8 into r, which is 1 over 2, raised 21 minus 1 over 2 minus 1. Therefore, your k is equal to the sum of 21 terms, right? Which is the answer to this. So let's go and find the answer to that and see what we get. If you punch that like that, it's going to be 5 over 8 into 1 over 2, all raised 21 minus 1, all over 1 over 2 minus 1. So you get that your k is equal to 1.25. There is your k. There is your k. Fine. Now we move. We move to 2.2, right? So maybe 2.2. So they are saying at 2.2.2, determine the value, at 2.2.2, they are saying determine the largest value of n for which Tn will be greater than 5 over 8 to 9. So they wanted to find the value of n so that your Tn is greater than 5 over 8192. Right? So they wanted to find the value of n so that your Tn is greater than 5 over 8192. Right? No problem. What is Tn? Tn is the nth term, which is Tn is equal to a r raised n minus 1. Right? Your a is 5 over 8 into r is 1 over 2 raised n minus 1. So we want the value of n so that we want the largest value of n, so Tn is greater than this. So in that case, your Tn, put it there, because this is Tn, right? Substitute it here. So you have 5 over 8 into 1 over 2 raised n minus 1 is equal to 5 over 8192. Right? So you divide both sides by 5 over 8, divide by 5 over 8. So this and this go away. So here we're left with 1 over 2 raised n minus 1 is equal to the answer to that. So let's find the answer to that. So say 5 over 8192 divided by 5 over 8. (8192) divide, right? So what you get is 1 over 1024. Right? That's what you get. So in this case, actually it shouldn't be equal to, because we want it to be greater than, so it should be greater here, should be greater here, because we said 1 Tn, the value of n, so that Tn is greater than that, so they should be greater here, not equal to. So in that case, we have 1 over 2 raised n minus 1 is greater than 1 over, factorize this, 1024. You get that is 10 raised, it's 2 raised 10. So what do we do? Let's take the 2 up and take that 2 up there. So what you get is 2 raised -1, right, into n minus 1 is greater than 2 raised negative 10. So your 2 raised negative n plus 1, because this 2 multiply both of those, is greater than 2 raised negative 10. So therefore, your negative n plus 1 should be greater than minus 10. Let's take the 10 to this side and the negative n to that side. So we have your 1 plus 10, you have 11, is less than n, right? Therefore, n is less than 11. So for, n is a natural number for on sequences, right? So if you're saying your n is less than 11, the largest natural number, it should be 10. So it should be what? So they said find the largest value of n. So therefore your n should be equal to 10. So 10 would be largest value such that your Tn is greater than that. Such that the Tn is greater than that. So 10 is the largest value where you are going to get this condition. After that, it will be less than. That's how question 2 looked like. And I hope it does make sense to you as it does to me. So thank you for watching. I'm going to do question 3 now.